So today we're going to have a look at what dominance matrices are and how we use dominance matrices. So let's pretend that we've got a round robin competition here between 5 teams. And this network that we've got shows which team beat which. So for example, Team A beat Team D and Team D beat Team E. What we can use dominance matrices for is to rank these teams against each other. So how we start with this is very much similar to how we start with connectivity matrices. We start listing out who beat who within our matrix. So A cannot play itself, so it didn't beat A. However, A, when they played B, didn't win, so that's going to be a 0. When A played C, they didn't win. When A played D, they did win, so we indicate this with a 1. And when A played E, they got the win, so we indicate that with a 1. And we continue until we've completed this matrix. Like I've done just here. So what I've got in front of me now is what we call a dominance matrix, which we refer to as D. How we use this to rank our teams is we actually consider the sum of each row. Now to find the sum of each row, we simply add each row together. So the first row will equal 2, the second one will equal 1, row 3 will equal 3, row 4 is 2, and row 5 is 2. And now we can use this matrix here, the sum of the rows of our dominance matrix, to help rank our teams. To do this, we look at this row sum of our dominance matrix, which shows us how many wins each team actually got. So Team A got 2 wins. They beat Team E and they beat Team D. Team B only got the 1 win, which was against Team A, and so on and so forth. So we can use this by just ranking them in the highest to lowest fashion. So we can see here that Team C had more wins than anyone else, so they're going to be ranked number 1. Then we've got a tie between Team A, D and E. And then finally we've got Team B who only had the 1 win. So they'll be ranked last. But we've now got this situation where we've got a tie between A, D and E, and we need a way to separate this tie. So one way we can do this is to start considering, if you beat a team, who did they beat? Or our 2-step sort of connections, which we can find by finding D squared. Now you can do this in a number of ways. Personally, I've already worked this out with a calculator, so I'm just going to put the values up here. Now, this D squared matrix shows us if you beat a team, who did they beat? So, for example, if we take Team A against Team B, Team A beat Team E, who also beat Team B. Team A beat Team D, who also beat Team B. So that's where our 2 value comes from. However, we can't consider this as strongly because what this is suggesting is Team A should be able to beat Team B because they've beaten 2 teams that have beaten Team B. However, if you look at the match between Team A and Team B beat Team A. So we can't consider this matrix as strongly. So when we start looking at it, we give it what we call an arbitrary value. So we multiply all these numbers by some value that we give it. In this case, I'm going to multiply them all by a half. So we look at a half D squared, which will halve every value that we've got here. Now we do this because we're going to add the second order matrix with the first order matrix, like this. Now, doing this allows us to do a new sum of each row, which helps us rank these teams by points. And we're doing this by looking at who did they win directly against, which was our D matrix, and of those teams they beat, who else could they theoretically beat by looking at who those teams beat, which is our D squared matrix. Remembering that we don't consider our D squared matrix as highly, which is why we multiply by a half value, that arbitrary value. So if we looked at the sum now, we can see that we've actually separated one of the three teams that were tied before. So Team D has now got a ranking value of 3.5 compared to Team A and E who have got ranking values of 4. So our new rankings are Team C is still top, which we'd expect. We've now got Team A and E tied still on 4. But we've separated Team D, which is now in that 4th spot. And finally, Team B, who only got the 1 win, which we'd expect to be in that last ranking spot. But how can we separate A and E? Well, we can separate these teams by looking at the third order matrix, which is matrix D cubed. However, D cubed has some inherent problems with it. Like if you consider the 3-step routes that exist here, we could say that A beat E, E beat B, B beat A, so A should be able to beat A. However, Team A isn't going to play itself. It's not going to beat itself. So we've got some problems here that we can't consider the third order matrix as highly as we considered the second order, and certainly not as highly as we considered the first order, which is who they actually beat. So if we were to consider the D cubed matrix, we'd have to give it an even lower arbitrary value that we multiply by. But this would allow us to further separate any teams that we've tied after this point. And we just continue in this fashion until we've got them all ranked clearly on their own. So in essence, what dominance matrices are used for is to help us rank different objects or different subjects against each other.